Okay, recording now. Yeah, so doing a lot of problems is probably one of the best ways to like prepare yourself for this material, in my personal opinion. So, where would you guys like to start? We could just start at 3.1. It's kind of like it feeds into one another, like 3.1, 3.2, and then we're going to do 3.5. So, okay, just going to start with 3.1. Okay. Let's start with problem 6. Have you guys done many problems from these sections before? Like, have you done many practice problems? And it's fine if you haven't, but I just kind of like, I don't want to beat a dead horse if you guys like know what you're doing. Okay, we have one yes. Awesome, doing problems this morning. You guys are on top of this. Okay. Would you guys know how to approach problem 6? Yeah, I kind of wanted to start off with a couple ones that were not quite as difficult so that we could like work towards it. But yes, for sure. We will get into some long problems. Exactly. So the derivative of this is going to be this is y prime or dy dx. We both have, this is just derivative. And this, one way that I find helpful is write this one as 3/3 because I've got a fraction with a 3 on the bottom. So the end product is going to be 4/3 x to the 1/3. Okay. Awesome. So what about number 10? Here we have, oh yeah, no, you don't need to worry about decimals. I just think about it in terms of like, here's a fraction, you can write it like this. This is a totally legitimate answer if you have a fraction up there. If the way that I kind of go is if they give you fractions like as the exponent, they should be able to take fractions in the exponent as an answer. So, okay. Yes, am I going to rewrite that? Perfect. Awesome. So we have this function that is f of x that is originally 1/x to the 4th, but that actually equals x to the -4th. And then I can go ahead and find f prime of x, which is, yep, okay. And is this going to be -3 or -5? Exactly, -5. Awesome. Wow, that took me a hot second to like get when I was first using it, but you guys are on top of this. Okay. So trick number 1 when it comes to doing these kind of problems, make sure that if there's something you can rewrite in something that you can actually work with, into a form that you can work with, rewrite it. So that's what this is doing. When fractions come around, just subtract 1 using like fraction like this, like 3/3. And then my last little tip for you guys is just basically a reminder that the square root of x is equal to x to the half. So you can switch between these at any time, because when you have a square root of x, you don't really know what to do with it, but you can take a derivative of this. Okay. That being said, this actually, if you ever get a problem, I don't know if they'll give it to you. This would be 4/3 to the cube root. So this basically is like, yeah, for sure, for sure. Yeah, okay. So just like the 3 reminders I would like put by you. fractions, square root / cube root, and rewriting it so that nothing's like in the denominator there. Okay, let's do an actually tough problem. Let's do 28. Okay, so we start like this. So we have several things that we need to clean up before we can actually find this answer. We're going to have y is equal to 3t squared. All of that is going to be the same. But this, we're going to move down. It's going to be plus 12t to the 1/2, because I know that the square root of t is equal to t to the 1/2. And then minus t to the -2, because this is going to come around to be t to the -2 instead of 1 over t to the 2. This is still not in a form that I really want to solve, so I'm going to rewrite it again. Y is equal to 3t squared plus, and then this is going to come down again. This is 12t to the -1/2. Just pop that back up like we did over here and make it negative. So same rule used for here and here. Minus t to the -2. Okay, so now this is something that we can actually solve. Okay, so we do these in parts, right? Because the derivative of this whole thing is their derivative of each of these individual parts added together, which is one really nice thing about this whole shindig of taking derivatives, is that they can give you a list like a mile long of just adding and subtracting things and adding and subtracting things, and all you have to do is take the derivative of each individual part and add and subtract them. So the answer, you have 3 times 2 t to the 2 minus 1 plus, sorry, I'm just copying this right out of the chat box, 12 the -1/2 t to the 1/2 minus 1 minus -2 t to the 2 -2 minus 1. Okay, that looks right to me. Simplify this to be sure. They're not going to accept this as an, like if you were to put this like on a test, like this wouldn't be one of the choices, because they want you to simplify it as much as you can. So it would be 6t. Yes, it should be. Yeah, you're right. There's a negative sign right there that I forgot, which would have been a bad deal. So negative. Okay. So this is 6t. Yeah, the bummer about all of this is that even though it's like once you get going, it's kind of easy. It's like if you forget one thing, the whole problem gets messed up. All right, so this is 12 over -6. Yeah, so this is going to be negative, and you can move the negative sign however you want to, but yeah. This is t to the -1/2 minus 2 over 2 minus plus 2, I don't know why I wrote a 4 there, it's 2 t to the -3. And so the end result is just going to be 6t minus 2t to the -3 over 2 plus 2t to the -3. And there's a lot of equivalents of this. Like you could write this term as minus 2t over x, or it's t. I don't know why I wrote x. This is 12 divided by 6. And it's t to the negative 3 over 2. You good? Awesome. Okay, so you could write this as negative 2t over t to the 3 over 2. You could write this. Why did I write t there? I'm sorry. I'm a little out of it today. That t should not be there. It's the t belongs down there where it should be. Okay, so you could also rewrite this using square roots if you wanted to. But this is just a fine answer, and this is what I would go with because you don't need to simplify it anymore unless you're bored. So that's problem 28. I'm going to clear the drawing, and then
Olivia, yes. 1 second. Isn't it 12 times 1 over 2 times a half, which would give
Oh my God, you're right. Oh my God, I'm so sorry.
Okay.
Oh my God. Okay. Okay. So I jumped the gun and my brain is fried. So here we have 12 times negative 1/2, which would turn out to be, this is just negative 6. So this is just negative 6, and this is, just ignore that for right now. But, oh my goodness. I'm so sorry, people. I'm so sorry. Okay. Did that clear up the glaring algebra issue? Yeah, that's even what I have written down on my paper. I'm so sorry, folks. Okay. Now that horrible mistake has been brought to light. Okay. Let's try to do let's do problem. Why don't you guys try to do 26? And like we will reconvene in like a couple minutes and we can talk about what answers you guys got. Okay. Yeah, this is still section 3.1. Do we think we've got some kind of an answer yet? Okay. We have one person saying 15t to the fourth minus 5 over 2t to the negative 1/2 minus 7t to the negative 2. Okay. That's right. This is t to the half minus 5. Yep, that's right. And that's right. Okay. Perfect. You guys did great. That's exactly it. Okay. Let's try 36, and then we can move on to section 3.2. Okay. So 36 looks like this. And I always tend to write it like this, like P of t instead of just P. And the reason I do that is so I know which one of these variables is the actual variable and which one of them are constants. If you look up at the top, it says that assume A, B, C, and K are all constants. So A and B are just constant numbers. They're not going to change. They're not variables. And that's why I put the T here as a way of reminding myself that T is the thing I'm concerned about. So if I'm going to find P prime of T, I need A prime plus bt to the 1/2 prime. So I know that the derivative of a constant is going to equal 0. Exactly. Yep. And then I say P prime of t is equal to b over 2 t to the 1/2 minus 2 over 2, or b over 2 t to the negative 1/2. So that is your answer here. Even though B is like a letter, because you need to multiply it by this. So it's 1/2 times B times T to the 1/2 minus 2 over 2, or 1. So it turns out to be B over 2T. Yeah, that's just like a way of simplifying it. Okay. Awesome. If there are no more specific questions about 3.1, we're going to move on to 3.2. Okay. So this is talking specifically about exponents and logarithms. So let's start off with problem 2, where we get to use some stuff from this section and some stuff from the last section. Okay, so something we learned in this section is that the derivative of e to the x is equal to e to the x. So, what would the derivative of this f of x be? Okay. But don't forget we have something added here, and we have another term including a variable. Yep, plus 2x, exactly. Okay, so, oops. We're not doing 3, we are doing, let's do 6. I don't know. This is problem 6. That doesn't look like a 6 even after all of that effort. Okay. What would the answer to problem 6 look like? Two. Okay. So this x is like a big, like this 2 to the x is a big like moment to trip up, because unlike e to the x, e is that special number where the derivative of e to the x, exactly. We're going to use the natural log of 2. Now, this is given to you in terms of a rule in your book, but if you forget this rule, you can actually figure out what the derivative of 2 to the x is by using, remember how when we were doing like interest and stuff, we would have like 2 to the x, and then we would also have like e to the, or like 2 to the t, and then e to the kt, where k is a constant. You can do that and like go through all of this work to figure out what k is to make it e to the kt equal to 2 to the 2 to the 2 to the t, and what k equals is the natural log of 2. So 2 to the t is equal to e to the natural log 2 times t. So in order to bring that, you bring that down every time you take a derivative. So we have y prime is equal to the natural log of 2 times 2x, and then minus, because we also have this chunk here, minus 6x to the negative 4. Okay. All right, so let's do problem 12, just as another kind of like skill builder. Like I said, really all you need to do with these is practice. So this is f of t is equal to e to the 3t. Given the rules in our book, where we find the derivative of e to the kt, we know that the derivative of e to the kt is equal to k e to the kt, or in this case it will be, go ahead and type it in the chat box. Yep, exactly. So yeah, and you can see that there's a way of these, conceptually speaking, like something that you're going to be doing later on is finding second derivatives, which is basically taking the derivative of a derivative. So if I were to take the derivative of this whole thing, f double prime of t would be equal to 9 e to the 3t, and so you can see this goes up pretty fast. Excuse me. Okay, the last problem, oh, thank you. On the last problem to go through. The problem 6. Okay. We're gonna quick go back and look at problem 6. which looks like this. Right? Because 2 over x to 3 is equal to 2x to the negative 3. So we agreed that this was the natural log of 2 times 2x. Yeah, no problem. And this comes down to be minus 6x to the negative 4. Okay. Okay, give me a sec. Why don't you guys take a look at problem. Let's do problem 26. Okay, what are you guys thinking about 26? You guys know what to do if you see a natural log stuck in the middle of a derivative? Awesome. The derivative of 26 is going to be, I know it's kind of a pain to type, so you can like abbreviate as much as you can. Well, we know this from the last is going to be 2t plus 5 times ln of t prime. So ln of t prime, where the derivative of the natural log of t is going to be equal to 1 over x, as kind of given by the book. So this is 1 over x, so y prime is equal to 2t plus 5 over 1 times 1 over x, or it's equal to 2t plus 5 over x. Why did I put x? It's t. It's t this whole way through. It's the same variable. All of those are t. They're all t. This function is y of t. Anyway, so you guys are comfortable with using natural logs?
Is that a rule that ln of e derivative equals 1 over x t, whatever variable you're using at the time?
Yeah.
Okay.
So the natural log of t is equal to 1 over t, and this is on page, sorry, I'm looking at it right now. This is on page 147. At the very top of the page. So, it also has like a really nice algebraic and like geometrical like justification for that. So that's cool. But okay. Yeah, no problem. There are certain rules that you're really going to want to commit to memory, and there are, like, honestly, you're not really going to have to try very hard, because if you do enough problems, they're just going to, like, you're going to have to use them like every problem. So one of those is the ln of x is equal to 1 over x, or the derivative of ln of x. Okay, let's take a look at section 3.5. And here we are dealing with the periodic functions. So let's start with problem 2 and problem 4. So take a sec, like go over, like write down the answers, put them in the chat box, and we can reconvene in like a minute. Sorry. Okay. So for number 2, that is exactly right. So y prime is going to equal 5 cosine x. Okay. For number 4, it's the same process. Yep. So y prime is going to equal 2t minus 5 sine t. Exactly. Okay. Awesome. So we're continuing in 3.5. Let's take a look at problems 8. And then let's do the problem with this section, doing 3.5 before 3.3 and 3.4, is that you guys don't have all of the necessary skills to do any problem in section 3.5. Okay? So like, for instance, if you were to look at number 10, you wouldn't be entirely sure how to do that. But if you were to do number 8 and number 14, you could do that based upon the rules that they've given you so far. So let's try 8 and 14. Don't panic about like 10 and 12 and like all those other ones quite yet. So problem 8. Anybody have an answer? Cos 3x. Okay. All right, we have one for 3 cos 3x and one for cos 3x. One of them is correct and one of them is not. The one that is correct is going to be f prime of x is equal to 3 cos 3x, because what's ever inside this thing has to get moved to the outside. Just like remember when we had e to the kt, if we took the derivative of this, we moved that k down. So that is equal to k e to the kt. So, yep. So this is the k, and it gets moved to the outside whenever we take a derivative. And that is the case every time there is something inside these parentheses. So if we're looking at trying to find the derivative of this thing, if this is equal to g of x, this is not a problem in the book, by the way, this is one that I just made up. G prime of x would be equal to 2, and then the sign would be negative sine 2t, because this never leaves. It's always going to stay where it is, but it does need to move to the outside every time you take a derivative. So the answer here would be -2 sine 2t. And the correct way of writing this is with parentheses here, so that you know it's the sine of 2t and not the sine of 2 times t, because that's very, very different. But I tend to forgo the parentheses rather frequently, if not always. Here it became a -2 because when you go from cosine to sine, you get cos x is equal to -sine x. And that's honestly really annoying to remember that negative sign every time, but it needs to happen. So just do it enough and you'll remember. Okay. Let's try number 14. Okay, so this is going to be z is equal to cos 4 theta. This is gross. Why did they need to use, like, they like to do this, they use theta instead of, like, other variables that you might be more comfortable with. Just note that this is z of theta, just like you would have f of x. So this is your function, this is your variable, theta is the variable. If it makes you more comfortable, you can rewrite z of theta is equal to f of x, and then rewrite the whole thing as cos for x is equal to f of x. But always remember, if they give it to you with this nasty variable in the middle, you need to put your answer with the nasty variable. So do whatever makes you most comfortable when you're solving these problems. But just keep in mind that, like, it's just the same as using f of x. That's also why I always rewrite it as z of theta. So if I need to find z prime of theta, I am going to look for, well, I know that this is going to have to come out. So it's going to be 4 times, and then it's going to be a negative sign because I'm going from cos to sine. I'm taking the derivative of cosine. And then it's going to be the same thing in the middle. It's going to be 4 theta. So z prime of theta is equal to negative 4 sine. Okay. All right. Thoughts on this material? Rank it 1 to 10. Go ahead and put your ranking in the chat box. What do you feel comfortable with? What do you not feel comfortable with? It's just a lot to process, I think. Yeah, the material is like, it's a lot of like, you have to like know what rules to use, but the more problems you do, I promise, the more comfortable you will be with like the material, like doing these. Okay. Things to remember. So we talked earlier about this, those tips from earlier, they still apply. So you have 9, are you talking about 3.5, the tangent line equation? Okay, give me 1 sec to wrap up this quick thing that I'm doing here. Okay, so all of those earlier tips and things to remember still apply, but I also encourage you guys to write everything down. Because it's so easy to get lost with this massive numbers and letters. I promise you, even when I'm doing, especially for next week, when I'm doing this, even though I've had like a ton of experience and like I've done this for however long, I still write everything down so that I know exactly like what I'm doing. Okay, so what part was confusing about the tangent line equation? Like, are you referring to a specific example? 23. Okay. This is a fundamental like definition of derivatives that oftentimes like you just like don't remember because you get so ingrained in doing the algebra of finding a derivative. But a derivative fundamentally is the tangent line. So when they're asking you to find the equation of the tangent lines and they give you those functions, all they want you to do is find the derivative. Because the derivative is a very general way of saying, like, okay, you give me any x and I'll give you what the tangent line is at that point. So I'm going to do something that's not quite periodic function. I'm going to do, give me a sec, that looked really bad. I'm going to do it in a reasonable color too. Okay. So say we have something that looks like this, without the little wave. So it's just a parabola. So in this parabola, we would say that here, the derivative is equal to 0, right? Why do we say that? Because the slope of the tangent line is equal to 0. We go back here, we say the derivative is positive because the slope of the tangent line is positive. And here we say the derivative is negative because the slope of the tangent line is negative. So all of that was kind of leading up to saying that the slope actually is the derivative. We know here the derivative is positive, the slope is positive. So the way that we would do this is we would say, so this is what? This is x squared, and it's moved some to the left. We do horizontal shifts by putting something inside. So let's not do this as a horizontal shift. Let's do this as a vertical shift because I don't want to mess with horizontal shifts right now. So this is, let's call this graph whatever it is, x squared plus 5. To find the derivative, so this is f of x. This graph is f of x. To find the derivative, we would say this is f prime of x is equal to 2x. That means that the derivative is going to be a line, and then plus 0 because this is constant. The derivative is a line, and the derivative is negative when x is negative. So the derivative is negative when x is being negative, and it's positive when x is being positive. That's obviously like not a very good artistic rendition of the derivative, but hey, that's weird. Give me a sec. Something's wrong here. Something is wrong. Okay. Oh, you know what I did? I missed a negative sign up here. The generic x squared function looks like this, not like this. If it's facing up like this, this is a negative x squared. So there's a negative sign out in front of that. So there's a negative sign in front of this. Okay. That being said, the derivative of this equation is negative 2x. So the when, for instance, we're at negative 4 right here, so this point on the graph, the slope is positive, so we assumed in our previous section's work that the derivative was going to be positive. Now we actually have an equation where we can go check that. So x is equal to negative 4, f prime of negative 4 is equal to 8, because it's negative 2 times negative 4, so it's a positive 8. Then we can say, okay, so remember how we said that the derivative was bigger here at negative 5? It was more steep than here at negative 4, or here at negative 2. So we can compare the derivatives from negative 5 and negative 2. So f of negative 2 is, or f prime, excuse me, we said the derivative was getting smaller and smaller and approaching 0. Here we can say the derivative is 4, and so the slope of the tangent line is going to be 4, and here it is 10. So the slope of the tangent line is actually larger here than it is here. And the slope is going to continually approach 0. So the whole point of this whole like rant and tangent line that I just went on, the whole point of the tangent I just went on was that the algebra that you're doing is intrinsically related to the geometry of what you've done. And you can compare them anytime. So when they say in problem 23 in section 3.5, find the equations of the tangent lines to the graph at this section 3.5 with this equation. Then what you need to do is you need to first find x or f prime of x, which in this case is just going to equal cos x. And then you need to find f prime of 0 and f prime of pi over 3. So to solve this problem, you would go f prime of 0 is equal to cosine of 0, and f prime of pi over 3 is equal to cos pi over 3. You could do the whole thing with the unit circle or use a calculator, whatever you want to do. But okay, that is how you would find the equation. That being said, like, okay, I don't think I made this clear, so like tell me if I'm beating a dead horse, but this generic equation can be used to find any like slope of the tangent line. Because it's like generic. So like this is the generic equation for the original function, and this is the generic equation for the derivative. And if I want to find the slope of the tangent line at 0, the slope of the tangent line at 0 literally equals this, because I just plug 0 in and that's how it works. If I want to find out at pi over 3, I just plug pi over 3 in. If I want to find it at 123, I just plug 123 in for x, and that's what the slope is at that point. So, that being said, thoughts? Nobody's saying anything. I guess I just did give you a lot to process. The slope is the cosine of pi over 3. Yeah. At the point pi over 3. So what this problem is asking you to do, let me see. Give me a sec to like unit circle this. Pi over 3 is what? That's 60 degrees. That's cosine. Okay. I think cosine of pi over 3 is a half. I really should know this, but it's not. What is this? The calculator might actually. Oh, I might be in. Oh, I'm in degrees. That's the problem. Oh, shoot. Okay. Well, yeah, okay, 0.5. So basically, what they're saying is that I'm going to clear all of this if that's okay. This problem is saying that at f prime of 0 is equal to 1, and then f prime of pi over 3 is equal to 1/2. And so now they're asking you to say, can you use this to estimate pi over 6? And the answer is yes, you can. You could say, okay, so if the derivative at this point is 1 and the derivative at this point is 1/2, what I can do is find the average rate of change between them, and that's likely going to be what the derivative is halfway between. Like, use this to find the midpoint. Or you could literally just put pi over 6 into the formula. So use each tangent line to approximate the sign of pi over 6. Would you expect these results to be equally accurate since they're taking equally far away from x? Oh, I see what they're doing. They want you to find, like, okay, so if I move pi over 6 in one direction, like, what is it? What is the sign going to be? And this is kind of relating back to average rate of change. I've never had a problem like this on a test or a quiz or anything like that that's asking you to do something like this, when so obviously the answer to find what you need to find is, like, right there. But give me a sec, guys. Okay. So sorry. Are there any questions about this? I don't think, like, doing the whole problem of 23 would be particularly, like, useful. But if you guys would like to do it, we can. Okay. Anybody? Yeah, I doubt they would have anything like this in the quiz or any exam. Okay. But yeah, I totally understand why it was confusing. Okay. Questions, comments, concerns? All of them? Feel free to say them. Okay. Well, seeing as there are no more questions, yeah, it is just about remembering the rules, getting some practice. If you guys come up with any questions, of course, feel free to email me, and I will help you out the best I can. Remember to write everything down so you keep track of stuff. And I'll see you next week when you guys are, oh, thank you. I will do my best. But yeah, remember next week, especially as you're doing some practice problems, write down everything when you're working on the chain rule. Okay, you guys have a good day.